cleavage can be described by perfect, good, fair, poor. And that just has to do with how well does the light reflect off of that surface? Is it kind of broken up? Is it more like you just see little bits of cleavage planes, or is the whole surface just a well-developed cleavage plane like you see in the calcite that we smashed that day? All right, these are just examples of cleavage planes. You can see these cleavage planes develop in the fluorite here. Fluorite has 4 different planes of cleavage. It's the only common mineral that does. Halite has, that's calcite, has 3 cleavage planes. Oh no, 2 directions, sorry. Cleavage in 3 directions for halite. Feldspar has 2 directions, and Muscovite only has 1, which is considered basal cleavage. Of course, things can fracture, like I mentioned, if they don't have preferential bonds that break in a specific way, right? So they can be conchoidal, like quartz, and this is an example of conchoidal fracture. You get those rounded, smoothed fractures. Obsidian breaks the same way as this quartz. There are a lot of minerals that do have conchoidal fracture. Irregular, even, is a rough surface with one or with some random irregularities. Hackly can be sharp-edged or jagged. Splintery and fibrous would be something like serpentine or serpentinite, which is a form of asbestos. And then luster and streak. So basically, I've already gone over luster or streak with you and how you determine that. Light is very, very important because we use it to determine how much actually reflects off of the mineral. Is it reflected? Is it transmitted? Or is absorbed? And that goes into 2 different things. Diaphaneity. So basically, is the mineral translucent, transparent, or opaque? And it also goes into the luster, which is how the light actually reflects off of the surface. All right, moving on. Metallic basically means that it is generally dominated by metallic bonds, and this is a galena, this is pyrite. You can see that metallic luster here. Non-metallic means it's generally dominated by ionic and covalent bonds, and those oftentimes have white streaks as well. Light transmission is possible. Metallic is 50% of incident light is reflected by the mineral. Let me go to, did I take it out? Here it is. So this is how we calculate luster, essentially. We use it, and it's called the index of refraction, or refractive index. Yeah, the transmission can be mixed. There can interference, and it can create iridescence in the case of labradorescence and pearls, not pearls, opals, and lots of, actually, types of plagioclase. Yep, that is correct. Birefringence is it's actually something I haven't really mentioned, but it is when you get 2 index of refractions that are or multiple, more than at least 1. All right. So an index of refraction has to do with this is how you calculate it. So it's basically the velocity of light in a vacuum divided by the velocity of light in the mineral. And most minerals have an index of refraction of 1.5 to 2. Things that have index of refraction over 2 are typically going to be metallic. These are also various terms we use to describe luster. Adamantine is something that is almost not exclusively used for diamond, because there are a lot of other minerals that can be adamantine in luster. But vitreous is super common for things like quartz. Earthy or dull would be things like talc. Yes, math and science, Doug. That's right. The few last things I want to mention is texture, feel, odor, like sulfur, actually. Now I'm gonna have to blow my nose like an ugly crier. A good cry is always freeing. I agree, Lynx. I think I just needed it. You're out! I had to get the boogers out of my nose. I'm sorry. I'm sorry. Sulfur. Where the hell did I put my sulfur? There it is. All right, I've got a little tiny sample of sulfur. I'll show you on the thing. But sulfur actually does have a very, very distinct smell. And a lot of times it isn't crystalline like this. This is a nice sample because you can actually see individual crystals that developed. A lot of times it just develops in a well, massive ball, and it's ugly. It's ugly. The smell is ugly. It's an ugly smell. So yeah, smell can actually be a diagnostic in some cases. Taste, again, is another diagnostic. This is halite. It's table salt. If you lick it, it will literally just taste like salt. I'm not gonna lick it because I've done it on stream a bunch. It literally tastes like salt. It's just salt. All right. There's a good example of why that one is particularly useful. There's another mineral, Sylvite, that has a very bitter and salty taste that apparently it looks very similar, and it's one way to differentiate the two. Additionally, no, you do not lick cinnabar because that one has mercury in it. It's only applicable in certain situations. If you are not a trained geologist, please don't lick the minerals, okay? Please. Because a lot of, especially the reds and the oranges and the yellows, those are oftentimes very toxic. They'll have sulfur or lead or mercury or arsenic or a myriad of other things you shouldn't lick. Jesus, you just don't do it, okay? Just don't do it. I'm trying to think. What if Mindat says to lick the mineral? Well, then it's probably safe to lick. But I don't think Mindat actually directionally tells anybody to lick the minerals. I think it just says whether or not it has health properties that should be dangerous or not. Mercury is not delicious, Felstar. Bad! And some minerals, for example, are also radioactive, like uraninite, which is another name for pitch blende also. All right, so taste, odor, texture, feel. Some minerals can actually feel somewhat soapy, like talc. It's one of the really, really good ways to identify it. And of course, effervescence is where you put the hydrochloric acid on certain minerals like carbonates, and they actually effervesce. We use dilute hydrochloric acid. It's 5 to 10%. All right. I was showing this mineral because this is the ethrite that thank you, Albul, that Hikari sent, and it looks so much better in the light. You can actually see all of the distinct colors. The azurite are the blue pieces. The ethrite is the red. All right, so sulfur is a good one for smell. Halite is a good one for licking because it's salt. It's literally table salt, so if you needed to use a taste test, that's a good example for that. I'm going to take this one out of the frame and put its little lid back on. Because it has a little box, and it's so cute. It's so cute. So, let's look at effervescence, yeah? You want to see something effervesce? I'm going to do... this piece of calcite. This one I dropped and broke up a bunch. And this has got a nice surface where it's kind of been crumbled a bit. Sometimes I like to... oh, there's my little apatite. Let's see. Quartz is harder than calcite, so I'm just gonna do this with it. That's actually another way you can determine hardness if you don't have a hardness kit, is just take a mineral that you know. This is a hardness 7. Quartz is a hardness 7, right? Take a mineral you know, just scratch it. I want to know if this effervesces, right? I want to know. I hope you can see this all right. So I'm going to drop a couple drops of hydrochloric acid. Oh, wow. Do you see those bubbles? That absolutely effervesces. Do you see that? Isn't that cool? Bubbles confirmed! Can I get a clip of that, actually? I really want a clip of that. I'm going to make it a highlight. Because it's hard to get that on camera. So that indicates that we have a carbonate. That means we know the chemical group of mineral it's in. The shape also suggests to me that, well, it's calcite. Additionally, if you place it on top of something, you'll see a refraction of the light through the mineral, and you'll see a double vision of what's beneath it. And you can see a second circle out of the other one. So the shape, the double refraction, and that effervescence to me suggests that this is calcite. And guess what it is? You could also do other things like a hardness test. We did scrape it with quartz, so we also know that it's not as hard as 7. So that also eliminates anything above a 7 in hardness. So you can do different things just like this to determine what its hardness is. Let me grab a 5.5 This is 5.5 hardness, right? Right? It's a glass plate. I'm going to try to scratch it. It did nothing. It absolutely did nothing. So it's not as hard as 5.5. So now we have even more information. We have even more information about that mineral. It's less than 5.5. But I wonder if I can scratch it with my fingernail. I wonder. And I can't. So your fingernail has a hardness of 2.5. So we now know this is actually between a 2.5 and a 5.5 in hardness. We have a crystal shape. We know what effervesces. This is the best way to identify these minerals in this case. Yeah, it's kind of a super complicated game of guess who in a way. Yeah, jalopy, exactly. I mean, you could always zap these things in a microscope and get a chemical composition, spit it back out at you, and then you can identify exactly what that mineral is. And you do need to do that with certain minerals. This can only take you so far. Especially if things are microcrystalline and you can't actually see a shape. I'm going to dry this off with my snot rag because I'm a fancy lady. Contaminate my snot rag. Oh, man. I'm going to throw it away now. Done. All right. So, all of that powder that I scraped up is basically gone. It reacted with the hydrochloric acid and turned into CO2. So, there's a little bit extra CO2 in here. It's not anything significant. But normally you would do this outside anyway. And again, all right, so now we've gone over some of the hardness things, right? We've gone over tests, different things. I don't really have anything magnetic. So there are some things, like if I were to try to test all these, none of them are magnetic. I don't have any magnetite, which is probably the best example that we could use. So the next thing I'm going to try is a streak plate. I want to know what the heck this is. I don't know, right? We have no idea. Let's try to find out. So we're going to do a streak plate test. All right, it has a white streak. Do you guys see that? Which is why we need a white and a black streak plate. So now we have a streak, right? I'm going to see if I can scratch it with my fingernail. And I absolutely cannot. Cannot. So I know it's harder than a 2.5. Well, let's see if I can scratch the streak plate. This is harder than a 5.5. Now, if I were to take a steel nail or drill bit, a 6.5, it would, I would be able, it would not, the steel nail that's a hardness of 6.5 wouldn't actually scratch this. So for the sake of it, because I don't have it here, pretend I tried, all right? And it didn't work. All right? So in that case, we then know it's harder than a 6.5, and it is. If I were to put some hydrochloric acid on it, it would not effervesce. So that eliminates the carbonates, right? And this is a bit harder because it doesn't have a crystal shape, but it's actually a microcrystalline form of quartz. We can use the streak, the hardness, the lack of effervescence, the lack of magnetism. It's actually brittle. If you were to smash it, you would find that out as well. And the luster, in this case, the luster is not good. It's dull at best, right? There isn't really any reflectance off of it like you would see on this one here. You see the planes, a light. Let's see if I can get it to rotate. There we go. Why is it frozen? No. I'm not good at angling this to get that light. There we go. So you see that plane? It's a very nice reflective surface. That luster there would be considered vitreous. So vitreous luster is also another property we can write down to figure out what this mineral is. Additionally, we've got this mineral here. It's exceptionally soft, and you can also bend it. This has got basal cleavage. Additionally, you could see the individual cleavage planes. And this is Muscovite. This is Muscovite. And it's got a hardness of 2. You can actually scratch it with your nail. This here actually has a hardness of 4. But this is fluorite. Additionally, you could use a UV and it would fluoresce. So that would be another giveaway. All right. So we've got streak. We've got hardness. We've got luster. We've got tenacity. Density. There's another one. This one here. This is an unusual one, right? It's different. The luster's even different. Let's see if I can get a nice plane to reflect. Do you see that slight reflectance? It's almost kind of pearly. It's not as shiny as some of the others, but you can see a little bit of reflectance. The point is the luster is very different. The other thing here is if you could hold this mineral in your hand. Yeah, it does. It does kind of look somewhat chalky. If you could see it in person, it would be more of a what's called a pearly luster. So the big takeaway though here, you can't see this one, but if you were to hold it up with this similarly sized mineral, all right, let's just hold these two, right? These two. They're kind of similarly sized, all right?
Fresh meat.
So you would see these. This is what we would do for a density test or a heft test, right? So you would hold two minerals of almost the same size, and if you could tell, this is halite, this is barite. Barite's actually exceptionally dense. It has a high specific gravity. So you can tell that, oh man, this is a dense mineral. Its luster's a little bit different. It's got an amazingly white streak, right? Let's see if it can scratch glass. It actually can't scratch glass. So now we know that it's not as hard as glass. It has a white streak. It's dense. It has a different, almost a little bit of a different luster than the other minerals. Those things are typically almost enough to identify that. And I want to get through the lab with you at some point. This one is exceptionally unique. And if you could see it, it has no luster. It's exceptionally dull. It doesn't have any real reflectance off of it. But if you were to literally just feel, this is where texture comes into play. It actually feels kind of greasy or soapy. And this is talc. It's also got a 1 on the hardness scale. It would make a white streak, of course. But you don't really, honestly, it's so soft. You can literally see the streak on the glass plate. It'll literally crumble. You could scratch it with your fingernail. You could actually see it on my hands. So these are various ways that we can identify minerals using HCl, using streak plates, using hardness tests, using density tests, using luster, using the shape of the minerals. You can see that these are cubic. This halite forms in cubes, 90 degrees, planes from one another. Right? So this shape is important too. In this case, you can see that this is hexagonal. But quartz doesn't always look like that. It can look fucking random. This isn't one that we would typically have in a classroom to identify. It would look more, I don't know. I've never seen anything this complex for somebody to try to identify. This would be something kind of mean to throw at a kid, I think, in a class. I wouldn't do it. That's kind of mean. You can use hand lenses, which I don't have, to look at detailed striations or fractures within the mineral that might indicate a cleavage plane, because those are important too. If you have the enough minerals to do so, you can always smash them to determine whether or not you have a cleavage plane, or if it just fractures, because fracture surfaces can also be very, very useful for this kind of thing. What's the other one? I wanted to show you gypsum. Oh, it's albite. This one's albite. Do you see that weird little luster? It's kind of, I don't know, it's like subvitreous maybe. It's almost vitreous. This is a very strange form of albite. I have another albite specimen here. Albite's one of my favorite minerals just because I can use it a lot for various science experiments and things. You can determine a lot with albite. It changes chemically at different temperatures and pressures underground, so you can actually use it to determine how much uplift has occurred in an area. And if uplift has occurred, there's two end members of this type of plagioclase, and this is the sodium end member. The other end member is anorthite, and it's the calcium end member. But this is albite, and this is albite as well. They're just two different varieties. This is actually a variety called Clevelandite, but they are about a hardness of 6. They're just another example of different minerals that kind of all look very similar. Like if you saw all these minerals together, would you be able to identify them had I not given you these basic, I guess, instructions? They look very similar, right? No, I know it's a variety called Clevelandite. Albite isn't normally vitreous albal. I think that specific variety is kind of is a little different. Question about this. I do want to know. Do you feel that these minerals, before the beginning of stream, would you have been able to tell them apart? And don't look at the numbers on them, okay? Just look at the not numbers. Just curious. No? Oh, he's too quiet playing it. Does he get super focused? One neurosurgeon. Yeah, that's fluorite. That's fluorite, Nini. Let me just show you a couple more minerals before I put all this away, because I'm excited and how pretty these are. Good God, they're so gorgeous. Here's some Apatite. Here's some Barite. Here's some more Garnet. Here's a different Garnet. Here's some Lepidolite. Here's some Aragonite. Here's some Wulfenite. Here's some Tourmaline. Oh, here's some rhodochrosite. Look at how pretty all these are. Good God. This camera does a lot of justice. So you can kind of see that salmony white color now that I couldn't really show to you guys before. It's so pretty, the barite is. This is another sample of barite with some cerussite on it there. That little white crystal, that's a carbonate. It's a lead carbonate. Fresh meat. And there's some Galena in here too, which is a lead sulfate. That metallic piece right there, that's Galena. Kyanite, it's a nice metamorphic index mineral. You can see it's got a hardness of 7 this way and 5 this way, which is why jewelers apparently hate using it. But it's got a decent luster, and it can it's really good at withstanding high temperatures and high pressures, which is why it's commonly found in metamorphic rocks, because that's where it typically forms. This is another carbonate. This is a aragonite, and the reason it is actually a muddy brownish orange is because it's trapped mud, literal mud or dirt or whatever, in the environment in which it grew, because typically aragonite is clear. Here's another little sample of aragonite that I have that I rather enjoy. I really like it. Wow, God, I love the camera so much. Oh my God, it makes me so happy. Here's the rhodochrosite, is a manganese variety of carbonate. I've been trying to fill up my carbonate collection just because I like it. Rhodochrosite is gorgeous. It can sometimes be this deep red color. I love it. It's not cheap though. Garnet, garnet, garnet. These are 3 different types of garnet. This is andradite, this is grossular, and this is euvorovite. This is only 3 of 6 types. Garnet can be a lot of types. Euvorovite is probably the most expensive that I've seen, and the crystals are real small, but they're very, very, very green. This is, I like these 2 a lot because of the deep brown reds. These 2 were from E-Rocks. This one was from a mineral show that I went to. This is Dioptase. This is one of my favorite minerals. It has copper in it. It usually forms in hydrothermal veins. This is Diopside. No. This is Diopside. This is Diopside. Sorry. This is Apatite. My bad. This is Diopside. This is Apatite. This is Dioptase. Confusing, right? But they're very pretty. And guess what, guys? None of these heal you. Did you know that metaphysical healing is all a placebo effect for your, well, literal health, I guess? This is Lepidolite. It's actually a mica. This is usually, it has basal cleavage, but this is a massive variety. So all these different sheets just kind of grew in a variety of different directions. But it's a nice purple lithium-bearing mica, which is pretty cool. Oh, Apatite. Apatite's really pretty. Apatite can be very cool looking. And sometimes used in jewelry. It's also hexagonal. Apatite can be all sorts of colors. That's why, again, it's not a great way to ID minerals off of color. Apatite can be all the colors of the rainbow. It's insane. So can quartz, basically. This is Wulfenite. It's a lead... it's a lead molybdate. That's right. Has molybdenum in it. Lead, molybdenum, and oxygen. You can find this in a lot of places in Arizona and Mexico. It's very specular. I love it. Very pretty. Very pretty. Oh, sphalerite. That's another, I think lead-bearing one. It's sulfur-bearing, at least. I don't remember what else is in it. No, lead sulfide is, Galena. This has got sulfur in it. I can't remember what else. But sphalerite was one of my favorites for quite a while. It's also pretty hefty and dense. So it's another way to determine. This is actually another form of gypsum. It's called desert rose. Barite can also form in a similar way. And it's pretty cool. Called desert rose just because it naturally takes that shape. So this is, I actually think this is barite. This is a dense piece of rock, man. And this is watermelon tourmaline in it. I love watermelon tourmaline, but it is not cheap. And I'm pretty sure that this is either barite or albite that it's in. I'm not 100% sure. I need to do more tests, but I really don't want to destroy it. It could be Clevelandite, which is the type of albite that we just looked at. I wish it would have said when it was purchased. And again, the garnet that I really like. I've got a ton of minerals, tons and tons of minerals to show you over the course of my Twitch career. The German...